Hello and welcome to the 109th IUVSTA workshop, the APPEC Technology Forum Vacuum Cryogenics, where industry meets academia. Today, we will have a short introduction by one of our invited speakers, Björn Schäffrand from DAISY, who will talk about the search for axion dark matter with various experiments.
I'm Björn Schäffrand from DAISY and working for axion detectors which we want or will operate here at DAISY. And my talk is named Vacuum and Cryogenic Technologies in Large Axion Detectors. Here's a short overview. I just want to go briefly through it. My talk will introduce you with a little bit physics, not too much because we have a technical workshop here. And then I will go further on with IUVSTA experiments, the setup for the YAXO, baby YAXO experiment, and later on the MADMAX experiment. And at the end, I will give a brief summary on all of this. What we are doing here at DAISY is more or less we try to cover three kinds of axiom experiments. The first one is the light shining through the wall experiment. This is a laboratory experiment where you try to shoot with a laser on a wall and try to find some light after the wall, because meanwhile axion light converts into axiom and back to light again in a magnetic field. So this experiment we make here, and we are already operating here at DAISY, is IUVSTA experiment. Second, we plan to install a helioscope. This is the YAXO, baby YAXO experiment here at DAISY, where we try to find some axioms coming from the sun. Also, light is converted into X-ray, and this X-ray we try to focus somewhere in a detector, and therefore we try to detect it. And the last one is an haloscope experiment called MADMAX. This is experiment where we're looking for axion or try to detect axion in our environment, and this would also be an evidence for an axiom that the axiom is dark matter in this case. All of these experiments require cryogenic and vacuum techniques, and I will just give a brief summary here, what I try to cover in my talk in the APPEC meeting end of November. So for IUVSTA, we have two strings of superconducting magnets, 24 magnets in total, operated at 4.3 Kelvin each. We have a vacuum tube for optics with the particle-less areas where we have the main optics installed. And later on, also important for cryogenic, we try to install a test sensor. This is an edge sensor where we try to detect single photons or very, very weak photons. Yes, IUVSTA will also cover everything on vacuum techniques and cryogenics. So the baby YAXO experiment, the second experiment here, is a 10-meter long superconducting dipole magnet operated at 2.1 Tesla. We have a cooling for these superconducting magnets, which is only provided by cryocooler and cryovents. In total, we have one area with 4.2 Kelvin, one area or one surrounding shield with 25 Kelvin, and a second shield with 50K, operated 50K. Then we have insulation vacuum with MLI, two warm bores with vacuum and partial pressure operation for some detection states. And also we tried, or we plan to use this for a complementary use for the RADIS experiments. This is a haloscope experiment where you not trigger the sun, but where you try also to look like magnets for axion in the environments with a high frequency copper cavity. And this cavity is also read at 2K, also relevant for this workshop. The MADMAX experiment, the magnetized disk mirror axiom experiment, makes also use of a big magnet. This magnet has a bore, is planned with a bore of more than 2.52 meters and a field of 9 Tesla. We have here in the middle a booster which boosts a very weak signal of an axiom, which is converted into an electromagnetic valve somewhere to this focusing mirror, and then this signal goes into a horn antenna or a receiver antenna, which is also operated at deep temperature. Yes, for this experiment, for MADMAX, we already installed so-called subcooler distribution box, where we are able to operate in one former halls of the experiment of H1 up to 3+1 cryogenic experiments. One of these is a 9 Tesla superconducting dipole magnet for MADMAX. This will be operated below 2 Kelvin. The experiment is hosted in an extra cryostat. Yeah, you can see it here. This wall is also a cold wall because we need to depress the signal-to-noise ratio, so to have a higher sensitivity for this experiment, and therefore we need a cold environment. And we have a lot of vacuum and cryogenic operation also for our sensorics and motors for the movement of the disk, which we use for boosting this signal. We need an adjustment of this disk in a cryogenic environment. This we do with motors, and to see whether we have the right position, we also plan to operate there some interferometers inside. And in addition, we have a cryostat for this everything, for testing these, and especially for testing the setup. We have already a cryostat which is hopefully commissioned end of November, and we are right now in the commissioning phase of this experiment. So that's it. Thank you very much.
Thank you for listening to the short introduction to topics of our 109th IUVSTA workshop, and we hope we can welcome you in Maastricht at the meeting on November 24 to 26.